We talked about need of hybridization in the previous lecture. If you apply valence bond theory to CH4, okay, it is found that in CH4 we'll have 3 carbon hydrogen bonds formed by sp overlaps and 1 carbon hydrogen bond formed by ss overlap. So valence bond theory is not sufficient to explain the exact shape of CH4 molecule and its structural features. As per valence bond theory, we'll have 3 strong bonds and 1 weak bonds. But experimentally, on experimental study of CH4 molecule, it was found that all the carbon hydrogen bonds in CH4 are identical. Okay. So to explain the structural features of CH4 molecule, to explain the bond parameters of CH4 molecule, okay, the concept of hybridization was introduced. Without hybridization, it was not possible to explain the identical carbon hydrogen bonds, okay, with the help of valence bond theory. ये हमने last time discuss किया था. ये point बताया था मैंने कि all the carbon hydrogen bonds in CH4 are identical and have a tetrahedral orientation. They are at an angle of 109 degree 28 minutes. Okay, they are all identical and an angle of 109 degree 28 minutes. और valence bond theory apply करेंगे तो we'll get 3 carbon hydrogen bonds are stronger than the other carbon hydrogen bond. Okay. Also, we'll get that 3 carbon hydrogen bonds which are formed due to sp overlaps are perpendicular to each other. That means at angles of 90 degrees. So these 2 points could not be explained with the help of valence bond theory. These 2 points contradict the experimental results. To explain the actual observations, the concept of hybridization was introduced. Okay. Now we'll explain what is hybridization. Okay. यहाँ तक clear है? कोई doubt है किसी को? Till now, any doubt? ठीक है. So we'll continue with chemical bonding, lecture 7. We'll discuss what is hybridization. Definition is, it is the intermixing and redistribution of energies of atomic orbitals of an atom before they overlap with other orbitals and form bonds. The intermixing and redistribution of energies of atomic orbitals before they overlap with other orbitals to form bonds. What happens in case of the CH4 molecule? For example, let us discuss the CH4 molecule. Carbon in the excited state is 2s1, 2p3. This is the excited state of carbon. There is 1 electron in 2s and 3 electrons in 2p. All the outermost orbitals, they intermix and hybridize. They undergo hybridization. It results in formation of 4 new orbitals. It results in formation of 4 new orbitals. These 4 orbitals, new orbitals, are called as hybrid orbitals. These are hybrid orbitals. These are called as sp3 hybrid orbitals. Why sp3 hybrid orbitals? Because they have been formed by 1 s and 3p. Therefore, sp3. 4 hybrid orbitals. These are all identical in shape, size, and energy. Having 4 electrons. Now it is the sp3 orbitals that will overlap with the s orbitals of hydrogen. Now it is the sp3 orbital that overlap with s orbitals of hydrogen, resulting in 4 identical sp3s overlaps. ठीक है, ये जल्दी से नोट कर लो. क्लियर है ये? एक सेकंड रुकना. So the sp3 orbitals overlap with the s orbitals of hydrogen. The sp3 orbitals of carbon overlap with s orbitals of hydrogen to give 4 identical sp3s overlaps, resulting in 4 identical carbon hydrogen bonds. ठीक है, क्लियर है ये? So 4 identical carbon-hydrogen bonds are formed due to 4 identical sp3s overlaps. sp3 orbitals of carbon and s orbitals of hydrogen. Okay. Now, one by one, we'll study some important features of hybridization. Then we'll study how to determine hybridization, different types of hybridization in molecules, and then how to determine the type of hybridization in a molecule. So, पहले features of hybridization. It takes place between atomic orbitals of comparable energies. तो जनरली अगर सेम शेल के ऑर्बिटल्स या फिर we can have the d subshell of penultimate shell also used in hybridization. So either the same shell or the penultimate shell orbitals take part in hybridization. So generally orbitals of same shell take part in hybridization. Sometimes d orbitals of penultimate shell may also take part in hybridization. The same shell is the outermost shell. Sometimes d orbitals of penultimate shell also take part in hybridization. Will not study hybridization involving f orbitals. Okay. Generally, covalent bonds are formed by non-metals. We're talking about covalent bonds. And F block metals, F block elements are metals. So very few compounds, we don't study compounds of F block elements in details क्योंकि F block elements के बहुत कम compounds हैं. And the main focus of study is representative elements. So we generally ignore the F block elements क्योंकि बहुत कम compounds discovered है, उनकी properties बहुत ज़्यादा depth में study नहीं करी गई है, तो we'll not talk about that. That is beyond the scope of our syllabus. ठीक है? So only d orbitals will include. The number of hybrid orbitals formed is equal to number of hybrid orbitals formed is equal to the number of atomic orbitals taking part in hybridization. नेक्स्ट देखो, hybrid orbitals form stronger bonds than pure atomic orbitals. Thus, we can say that they have greater directional character. They have greater directional character because more directional character results in more extent of overlap, resulting in stronger bond. Higher electron density in a particular direction. They have greater directional character than even a p orbital. So accordingly, shape of hybrid orbitals have been proposed as this. The shape of hybrid orbitals is such that it has higher electron density in a particular direction. It is similar to a p orbital, but one lobe is a smaller lobe and one lobe is a larger lobe. This is the shape of a hybrid orbital. All hybrid orbitals have been assigned a similar shape. ये प्रीवियस पेज देखो एक बार जल्दी से. हो गया? $66 on 80 विरोक कौन से टॉपिक वाइज टेस्ट में आ रहा है तुम्हें? 66 on 80. Aim higher. Periodic table के टेस्ट में you could have scored full also. But ठीक है, okay. 70+ मिला क्या किसी को? 70+ out of 80. Good, Soumya. 75. Aditya also 75. Ansh, कितना मिला तुम्हें? Aryan, how much you got? Ishan 76. Good. Aryan 70. Good. Rhythm 76. अंश कितना मिला तुम्हें? सार्थक सुबह पोस्ट कोई सुन नहीं रहा है? Utkarsh 66. 60+ is good. 70+ is very good. Below 40 is very bad. 40 to 60 is okay. देखो, if you are doing the class notes thoroughly and booklet thoroughly, the TWTs में you will score good. पीरियोडिक टेबल के TWT तो इजी होंगे. पीरियोडिक टेबल में बहुत ज्यादा डिफिकल्ट क्या ही पूछ सकते हैं. If you are thorough with your class notes also, then also you will be able to do score good in periodic table. Okay. But if you are not reading the notes properly, okay, going through the notes properly, doing the booklets thoroughly, doing the assignments, okay, and discussing them, taking part in your discussions. I'm observing that you people are not actively discussing. Class में discussion बहुत कम हो रहा है. Doubts कोई नहीं पूछ रहा है. Okay, if you are solving, you will have doubts. ठीक है, अगर doubts पूछोगे, then you will learn. So try करो to make the class more interactive. Try to ask more doubts. Okay, it will be in your benefit. ऐसे कोई फिक्स नहीं होता है ये आर्यमान की 80 मार्क्स का पेपर होगा या 100 मार्क्स का पेपर होगा. There is no fixed pattern. थोड़ा बहुत कभी-कभी शेड्यूलिंग होती है. Don't worry about it. Anya is 76. Good. Periodic table में numericals काफी कम है. Only from some applications of electronegativity. Electronegativity में we have a few numericals, ionization energy also. But ऐसे numericals काफी कम है periodic table में. Mostly we have theoretical question. हाँ, Z effective में भी है. थोड़े ionization energy extra में भी है, but normally काफी कम है. कुछ बोल रहा है विरोक? So let us continue this. So hybrid orbitals form stronger bonds than pure atomic orbitals. Just you can say that they have greater directional character. They have higher electron density in a particular direction. They have one larger lobe. So this is the characteristic shape of hybrid orbitals. We have one larger lobe and one smaller lobe. Next point, लिखो. Hybrid orbitals almost always form sigma bonds. There are very few examples of hybrid orbitals forming pi bonds. Hybrid orbitals forming pi bonds एक ही example है जो organic में करेंगे हम. There's a molecule called as benzene. In benzene, we have triple bond between 3 carbon atoms. It has one pi bond formed by hybrid orbitals. तो अभी explain नहीं करूंगा मैं कैसे, but organic chemistry में पढ़ेंगे ये. It has one pi bond formed by hybrid orbitals. They almost always form sigma bond. They form stronger bonds, and stronger bonds are formed because of axial overlaps. They almost always form sigma bonds. ठीक है? We were talking about features of hybridization. Fifth point लिखो. The hybrid orbitals formed orient themselves around the nucleus in such a manner that repulsion between them is minimized. In such a manner that repulsion between them is minimized. हो गया, अभी टर्न करूं? आवाज आ रही है? एक सेकंड रुको, मुझे ठीक करो। अभी ठीक है आवाज? ठीक है, नेक्स्ट देखो। Hybrid orbitals orient themselves around the nucleus in such a manner that repulsion between them is minimized. So this will also discuss in valence shell electron pair repulsion theory. This point we'll also discuss in this VSEPR theory. This is a point that is also covered in VSEPR theory. The hybrid orbitals are oriented in such a manner that repulsion between them is minimized. Let us now discuss different types of hybridization. This point, the last point, it actually explains the shapes of molecules. Now let us discuss different types of hybridization one by one. सबसे पहला है sp hybridization. One s and one p orbitals intermix to form two sp hybrid orbitals. One s and one p intermix to form two sp hybrid orbitals. दो sp hybrid orbitals बनेंगे. They get oriented in such a manner that repulsion between them is minimized. Repulsion is minimized by maximizing the distance between them. They get oriented opposite to each other. एक हाइब्रिड ऑर्बिटल अगर लेफ्ट की तरफ डायरेक्टेड होगा, दूसरा हाइब्रिड ऑर्बिटल राइट की तरफ डायरेक्टेड होगा. ठीक है. The angle between the two hybrid orbitals will be 180 degrees. This is said to be a linear arrangement. The two hybrid orbitals get arranged in a linear manner, linear fashion. Still faint voice.
Then talking about sp2, 1s and 2p orbitals intermix to give 3 sp2 orbitals. There are 3 hybrid orbitals. They get oriented in such a manner that repulsion between them is minimized. It will be done by maximizing the distance between them. Orbitals are regions of high electron density, and electrons will repel each other. This is how sp2 orbitals are oriented around the nucleus, resulting in angles of 120 degree. This arrangement is often referred to as a trigonal planar arrangement. Turn करूं page. Next we have sp3, 1s and 3p orbitals intermix to form 4 sp3 hybrid orbitals. They get arranged in 3D in a tetrahedral orientation. It's a 3-dimensional orientation. यहाँ पे देखो हमने smaller lobes draw नहीं किए. Smaller lobes are insignificant. No need to draw the smaller lobes. हम चारों hybrid orbitals के केवल larger lobes draw करना है और उनके बीच का हम angle measure कर सकते हैं. It is a perfect symmetrical shape. Perfect symmetrical shape with angle between them as 109 degree 28 minutes. So this is theta. Theta is 109 degree 28 minutes. We join these 4 corners along with these 4 orbitals are oriented. We'll get a 3-dimensional structure which is called as a tetrahedral. चारों corners को join करोगे, we'll get 4 equidistant corners. We get a 3-dimensional structure which is called as a tetrahedral. It's a 3D structure. The 3D structure is such that all the angles are identical. Okay. तो ये टेट्राहेड्रल स्ट्रक्चर काफी इंपॉर्टेंट है. विल बी revisiting this tetrahedral again and again in various molecules. It's important to understand that all the four corners are equidistant and angles between any two orbitals will be 109 degree 28 minutes. ठीक है. तो टेट्राहेड्रल को समझने के लिए let us think of a cube, small cube जैसा visualize करो. एक सेकंड, draw it. How to get a tetrahedral structure from a cube? So these four corners are all equidistant from each other. ये चारों corners एक दूसरे से equidistant है. This actually forms a tetrahedral structure. These are all also equidistant from the center of the cube. The center of the cube is somewhere here. These are all equidistant from the center of the cube. यहाँ एक ऑर्बिटल है, यहाँ एक ऑर्बिटल है, यहाँ एक ऑर्बिटल है, यहाँ एक ऑर्बिटल, टेट्राहेड्रल ऑर्बिटल. ठीक है. All the four orbitals are identical. These are all equidistant from all the four corners. और angle between any two orbitals is 109 degree 28 minutes. आ रहा है समझ में क्या ये? तो ये जो टेट्राहेड्रल स्ट्रक्चर है, इसके चार कॉर्नर्स को कभी कभी हम ऐसे रिप्रेजेंट करते हैं. ठीक है. One orbital along this direction, one orbital along this direction, one orbital along this direction, another orbital along this direction. ठीक है. एंगल बिटवीन एनी टू ऑर्बिटल्स, जितना एंगल यहाँ थीटा है, सेम एंगल इधर भी थीटा है. सेम एंगल दिस इज आल्सो थीटा. ठीक है. इवन द सेम एंगल इज देयर बिटवीन these two orbitals. ये सब थीटा है. And all these theta is equal to 109 degree 28 minutes. ठीक है. All these are equidistant from each other. आ रहा है समझ में? क्यूब पार्ट समझा नहीं ठीक से. देखो क्यूब पार्ट में एक बार वापस से ड्रॉ कर देता हूँ, थोड़ा और अच्छे समझेगा. इसमें से चार इक्विडिस्टेंट कॉर्नर्स हम विजुलाइज करते हैं. जस्ट थिंक ऑफ फोर इक्विडिस्टेंट कॉर्नर्स. These are all equidistant from the center of the cube. क्यूब का सेंटर यहाँ कहीं है. These are all equidistant from the center of the cube. ठीक है. एक ऑर्बिटल अगर ऐसा है, दूसरा ऑर्बिटल ऐसा है, इन चारों कॉर्नर्स को अगर ज्वाइन करोगे तो एक टेट्राहेड्रल स्ट्रक्चर बनेगा. आ रहा है समझ में अभी आदित्य? सपोज ये कॉर्नर्स को मैं नंबर कर देता हूँ, कॉर्नर्स 1 2 3 4, और ये बीच में जो सेंटर है उसको मैंने 0 लिखा। तो एंगल 104 इज इक्वल टू एंगल 103 इज इक्वल टू एंगल 102 इज इक्वल टू एंगल 203 is equal to angle 204 is equal to angle 304. Angle between any two orbitals will be 109 degree 28 minutes. ठीक है, this is a perfectly symmetrical structure. आ रहा है समझ में? टर्न करूं पेज? Then we have sp3d. sp3d में 1s 3p and 1d intermix and hybridize to form 5 sp3d hybrid orbitals. sp3d में mostly it's the dz square orbital that takes part in hybridization. So s, px, py, pz and dz square takes part in hybridization. ठीक है, तो इसमें से इसको मैसेज समझ सकते हैं, दिस इज सिमिलर टू sp2 प्लस pz प्लस dz स्क्वायर। इसका जब शेप बनाएंगे तो sp2 का शेप कैसा होता है? ट्रायगोनल प्लेनर। So this will result in 3 orbitals similar to sp2 in trigonal planar arrangement in xy plane. Three orbitals in trigonal planar arrangement in xy plane, and pz and dz square will result in 2 perpendicular orbitals. तो कुछ ऐसा ओरिएंटेशन हम ड्रॉ कर सकते हैं इसके लिए, sp2 के लिए, सॉरी sp3d के लिए। We'll have 3 orbitals in xy plane along the corners of an equilateral triangle. ठीक है, and will be 1 orbital above it and 1 orbital below it. So we'll have 3 orbitals along the corners of an equilateral triangle. इसको सपोज करो हम xy प्लेन पे एज्यूम करेंगे, and there are 2 orbitals perpendicular to it along the z axis. ठीक है, ये वाला z एक्सिस याद करो, pz is directed along z axis, dz square is also directed along z axis. So pz and dz square contribute to the hybrid orbitals formed along z axis. S, px and py orbitals contribute to the hybrid orbitals formed in the xy plane. This particular arrangement is called as trigonal bipyramidal. Trigonal bipyramidal. बाईपिरामिडल दो पिरामिड है, एक ट्रायंगल है और ट्रायंगल के ऊपर एक वर्टेक्स है, एक पिरामिड जैसा स्ट्रक्चर ऊपर बना, और ट्रायंगल के नीचे एक वर्टेक्स है, एक पिरामिड जैसा स्ट्रक्चर नीचे बना. ट्रायगोनल बाईपिरामिडल. आ रहा है समझ में? We classify two different types of hybrid orbitals here. We get three equatorial orbitals. The orbitals in one plane are called as equatorial orbitals, and we get two axial orbitals. So the angle between the equatorial orbital, suppose it is theta. Angle between axial and equatorial, suppose it is phi. The value of theta is 120 degree, value of phi is 90 degree. आ रहा है समझ में ये? Axial and equatorial, यहाँ पर देखो, we have three orbitals in one plane. The orbitals along the corners of an equilateral triangle. We are referring to those three orbitals at the equatorial orbitals, and remaining two orbitals which are directed along z axis, we are referring to them as the axial orbitals. Understood? So the axial and equatorial orbitals are slightly different here. They will not be identical. It's the equatorial orbitals which have more of s character, and the axial orbitals have less of s character. Because the s orbitals participate in the equatorial hybridization but not in the axial hybridization. ठीक है, देखो sp और sp2 के शेप्स में भी हम बोल सकते हैं. एक और पॉइंट देखो, यहाँ पे मैंने क्या बताया, लीनियर शेप बताया. अगर s के साथ px का हाइब्रिडाइजेशन होगा तो द ऑर्बिटल्स आर फॉर्म्ड अलोंग x एक्सिस. s के साथ अगर py का हाइब्रिडाइजेशन होगा तो ऑर्बिटल्स विल बी फॉर्म्ड अलोंग y एक्सिस. अगर s के साथ pz का हाइब्रिडाइजेशन होगा तो ऑर्बिटल्स विल बी फॉर्म्ड अलोंग z एक्सिस. आ रहा है ये पॉइंट समझ में? सिमिलरली sp2 में भी हम बोल सकते हैं s plus px plus py, it will result in hybridization along xy plane. S plus px plus pz, it will result in hybridization in yz plane. And similarly, if s hybridizes with py and pz, sorry, यहाँ आ जाएगा xz प्लेन और यहाँ आ जाएगा yz. आ रहा है समझ में ये पॉइंट? नोट कर लो जल्दी से। नेक्स्ट देखो, इक्वेटोरियल एक्सियल, वापस क्या बताऊं इसमें विरोध, जो तीन ऑर्बिटल्स ट्रायंगल के तीन कॉर्नर्स के अलोंग है उनको हम इक्वेटोरियल बोल रहे हैं, that are in xy plane, and the two orbitals that are perpendicular to it along the z axis are the axial orbitals. अभी तक जितने भी हाइब्रिडाइजेशन किए हैं हमने, इसमें से केवल sp3d में we have equatorial and axial orbitals which are different from each other. Next, more hybridization types we'll discuss for now are sp3d2 and sp3d3. sp3d2 1s 3p and 2d hybridized to form 6 sp3d2 hybrid orbitals. 6 sp3d2 हाइब्रिड ऑर्बिटल्स कैसे अरेंज्ड हैं? s dx dy z plus dx square minus y square plus dz square. In orbitals का hybridization, it results in formation of two hybrid orbitals each along the 3 coordinate axes, along the x-axis, y-axis and the z-axis. ऐसा शेप बनाएंगे. Suppose we draw all the 3 axes which are perpendicular to each other. एक x है, एक y है, this is the x-axis, this is the y-axis, and this is the z-axis. The hybrid orbitals are formed 2 along x-axis, 2 along y-axis, and 2 along z-axis. Okay. This is how is the shape of the orientation of orbitals in an sp3d2 hybridization. If we join these 6 corners form an octahedral shape. कैसा shape आएगा? Octahedral shape. The angle between the orbitals is 90 degree. इधर से भी मेजर करो, ये थीटा is equal to clear है ये? Octahedral has 8 triangular faces. All these triangular faces are perfect equilateral triangles. ऐसा समझो कि ये 4 corners, these are 4 corners along the corners of a square. 4 sides हो गए, इनको ऊपर वर्टेक्स से कनेक्ट करेंगे तो 4 ट्रायंगल ऊपर बनेगा, 4 ट्रायंगल नीचे बनेगा. You get a total of 8 faces, 8 triangular faces. आ रहा है समझ में? And last we have sp3d3 1s bp and 3 d orbitals intermixed to form 7 sp3d3 hybrid orbitals. एक बार प्रीवियस पेज का नोट कर लो जल्दी से. नेक्स्ट देखो 7 sp3d3 hybrid orbitals जिसमें कौन कौन से ऑर्बिटल्स यूज होंगे. ठीक है, तो तीनों यूज हो रहे हैं. dx square minus y square dxy. काम करो, we'll write it slightly differently. dx dy dx square minus y square dxy dz and dz square. If we consider the first 5 orbitals, these are orbitals in xy plane. Px is along x-axis, py is along y-axis, dx square minus y square is along x and y-axis, dxy is between x and y-axis but in the xy plane. So first 5 orbitals result in formation of 5 equatorial orbitals in xy plane. And pz and dz square result in 2 axial orbitals. कुछ ऐसा रिप्रेजेंट कर सकते हैं। You'll have 5 orbitals along the corners of an regular pentagon. Five orbitals along the corners of a regular pentagon. These constitute or form the 5 equatorial orbitals. And 2 orbitals perpendicular to it along the x-axis, along the z-axis, एक ऊपर और एक नीचे. तो regular pentagon के along जो 5 orbitals हैं, those 5 orbitals will be in the xy plane. In the xy plane, this is the z-axis. 5 orbitals in xy plane, 5 equatorial orbitals, and 2 axial orbitals. If we look at the angles between the orbitals, the equatorial orbitals will be separated by angles of 72 degrees. Regular pentagon में angle 72 आएगा. और equatorial axial are perpendicular to each other, उनके बीच का angle आएगा 90 degree. आ रहा है समझ में ये? This particular shape is called pentagonal bipyramidal. This shape is called pentagonal bipyramidal. आ रहा है समझ में? Call it as pentagonal bipyramidal. Similar to trigonal bipyramidal. आया क्या समझ में विरोक? आदित्य? सौम्या समझा? talk about steric number rule to determine hybridization. Important point है, all the sigma bonds are formed by hybrid orbitals and normally the lone pairs, the non-bonded electron pairs also occupy the hybrid orbitals. Therefore, we can say that the number of hybrid orbitals on an atom equal to the number of sigma bonds plus number of lone pairs on it. This is also known as the steric number. Number of hybrid orbitals को हम steric number भी बोलते हैं. Also known as steric number. N. And as per the steric number, we can find out the hybridization. Steric number gives the number of hybrid orbitals. The number of hybrid orbitals is 2. Hybridization will be sp. Number of hybrid orbitals is 3. Hybridization will be sp2. If it is 4, hybridization will be sp3. If it is 5, it is sp3d. If it is 6, it is sp3d2. And if it is 7, it is sp3d3. बहुत straightforward rule है ये. Steric number short में SN. तो steric number से हम hybridization निकालेंगे. Number of hybrid orbitals is 2. Hybridization will be sp. 3 it is sp2. 4 it is sp3. 5 it is sp3d. 6 it is sp3d. 7 is sp3d. Turn करूँ पेज. तो स्टेरिक नंबर डिटरमाइन करने के लिए हमें सिग्मा बॉन्ड्स और लोन पेयर्स निकालने पड़ेंगे. इसके लिए हमें लुईस स्ट्रक्चर ड्रॉ करना पड़ेगा. ठीक है. लुईस स्ट्रक्चर अगर हमें पता है, लुईस स्ट्रक्चर ड्रॉ करने के बाद वी कैन काउंट द नंबर ऑफ सिग्मा बॉन्ड्स, वी कैन काउंट द नंबर ऑफ लोन पेयर्स एंड अकॉर्डिंगली वी कैन फाइंड आउट द हाइब्रिडाइजेशन. एग्जांपल्स देखो. जल्दी नोट करो. Let us look at some examples. XCO2F2. याद करो हमने लुईस स्ट्रक्चर ड्रॉ किया था. जेनॉन सेंट्रल एटम, 2 ऑक्सीजन और 2 फ्लोरीन सराउंडिंग एटम. Oxygen will be bonded by a double bond. Chlorine will be bonded by a second. We will count the number of electrons drawn on xenon. 1, 2, 3, 4, 5 and 6. Xenon पे normally कितने electrons होते हैं? 8. 6 bonded है, that means there will be one lone pair. Now we will count the number of sigma bonds and number of lone pairs on xenon. ठीक है, हम generally central atom का hybridization निकालते हैं. The steric number of xenon will be equal to number of sigma bonds. ठीक है, टोटल नंबर ऑफ बॉन्ड्स तो 6 हैं. 2 डबल बॉन्ड है, 2 सिंगल बॉन्ड है, टोटल 6 बॉन्ड्स हैं. बट डबल बॉन्ड में एक ही सिग्मा बॉन्ड. डबल बॉन्ड हैज 1 sigma 1 pi. It has a total of 4 sigma bonds and 1 lone pair. Total steric number will be 5. Hybridization will be sp3d. समझा? Simple है. We'll count the number of sigma bonds, we'll count the number of lone pairs and accordingly find out the hybridization. You can have multiple central atoms within a molecule. जैसे let us consider CH3 COOH. यहाँ पे we can find out hybridization of each carbon and oxygen atoms. इस कार्बन का निकालेंगे. There is no lone pair on the carbon. It has 4 sigma bonds and 0 lone pairs. Steric number कितना आ गया? 4. Hybridization क्या आ गया? Consider the second carbon. It has how many sigma bonds? Actually 4 bonds हैं. बस 4 bonds में से एक डबल बॉन्ड है. डबल बॉन्ड has only 1 sigma bond. The steric number will be 3 sigma bonds. No lone pair. Steric number is 3. Hybridization is sp2. Now talking about this oxygen. इस ऑक्सीजन की बात करेंगे. It has 2 sigma bonds plus 2 lone pairs. Steric number 4. Hybridization of oxygen. आ रहा है समझ में? Are you getting this point? If you know the Lewis structure, you can find out hybridization for the atoms involved. तो Lewis structure draw करना मैंने पहले सिखाया था. Second one, this compound is acetic acid, CH3COOH, carboxylic acid. We have already done how to draw Lewis structures. बहुत सारे practice भी किए हैं. Lewis structure के basis पे हम आसानी से hybridization निकाल सकते हैं. ठीक है, कुछ और examples देखते हैं. Turn करूँ ना page? ICl4 minus. याद करो. You will take the negative charge on the central atom. Iodine bonded to 4-chlorine and will take negative charge on the iodine atom. Iodine पे total 7 electrons होते हैं, but -1 charge है, मतलब will draw 8 electrons on iodine. इसमें से 4 already bonded हैं, तो 4 और electron बनाना है, मतलब 2 lone pair. Steric number निकालेंगे iodine का. There are 4 sigma bonds and 2 lone pairs. तो steric number क्या आ गया? 6. Steric number 6. Hybridization is sp2. आ रहा है समझ में? पेज टर्न करूं? नेक्स्ट देखो, is also a formula to determine the steric number. This formula is applicable for monocentric molecules or ions. We'll do a formula to calculate steric number. For monocentric molecules or ions. Formula will write steric number is equal to V plus G minus C by 2. Number of valence electrons in a non-bonded atom in the free state. G is number of monovalent atoms or groups attached. Monovalent atoms or groups such as hydrogen, chlorine, bromine, chlorine, iodine, etc. C is the charge with sign. Charge on the. Let us apply this formula to find out steric numbers. कुछ existing examples करते हैं. एक CO2F2 जो हमने स्ट्रक्चर ड्रॉ करके किया था वही वाले एग्जांपल्स देखते हैं. CO2F2 हम steric number xenon का निकालेंगे. Steric number of xenon. How many valence electrons? Xenon has 8 valence electrons. How many monovalent atoms? Only fluorine is monovalent. Oxygen is divalent. 2 fluorine atoms. There is no charge. 0 divided by 2. Steric number 5 आ गया. Hybridization sp3 दिया है. ये हमने निकाला था जो स्ट्रक्चर ड्रॉ करके भी. ठीक है. Let us consider ICl4 minus. We'll find out steric number of central atom iodine. How many valence electrons? Iodine has normally 7 valence electrons. How many monovalent atoms attached? 4 monovalent atoms. All chlorine atoms are monovalent. What is the charge? Charge is -1 divided by 2 is equal to 6. Steric number 6. Hybridization is sp3. ये hybridization हमने लुईस स्ट्रक्चर ड्रॉ करके भी निकाला था. आ रहा है समझ में? Are you getting this? जल्दी से नोट कर लो. We'll do more examples. This formula has a limited application, valid only for monocentric molecules or ions. Normally surrounding atoms के लिए hybridization does not make much sense. Hybridization is a concept which is used to explain the shapes, structures. Surrounding atoms पे एक ही direction में एक atom attached है. There is no other atom attached to surrounding atoms. So surrounding atom to hybridization does not make sense. Still we can find out the hybridization. ठीक है, फ्लोरीन पे निकालेंगे अगर हाइब्रिडाइजेशन तो फ्लोरीन पे देखो यहाँ पे हमने लुईस स्ट्रक्चर ड्रॉ किया था. फ्लोरीन पे वी हैव 1 सिग्मा बॉन्ड्स एंड 3 लोन पेयर. फ्लोरीन का अगर स्टेरिक नंबर निकालेंगे तो 4 आएगा, तो फ्लोरीन का हाइब्रिडाइजेशन sp3 आएगा. ठीक है, क्लियर है ये. एक और पॉइंट है जो हमने फीचर्स ऑफ हाइब्रिडाइजेशन में नहीं लिखा था, वो ऐड कर लेना. मैं बता देता हूँ फीचर्स ऑफ हाइब्रिडाइजेशन, ये वाला पॉइंट ऐड कर लेना. टोटल हमने कितने 5 पॉइंट्स लिखे थे, एक और पॉइंट ऐड कर लो. इट इज अ हाइपोथेटिकल कंसेप्ट. हाइपोथेटिकल कंसेप्ट मतलब it is used only to explain the shapes of molecules. Okay, it is used only to explain the shapes of molecules. Okay, as such there is no evidence कि orbitals actually mix हो रहे हैं कि नहीं mix हो रहे हैं. Okay, just that कि without help of hybridization we will not be able to explain the bond parameters of a molecule. It's only with the help of hybridization we will be able to explain the bond parameters of a molecule. So there are a few molecules, okay, which we'll study later on, in which will not be needing hybridization. We'll be able to explain the bond parameters with the help of pure atomic orbitals only. In such cases, we say that there is no hybridization. The hybridization, we say that it is a hypothetical concept. हाँ, विरोध क्या बोल रहे हैं? Steric number of fluorine in XeO2 F2 XeO2 F2 is 4. But अगर क्वेश्चन पूछा what is the hybridization in XeO2 F2, normally we always refer to hybridization of the central atom. Okay? किसी भी कंपाउंड में अगर हाइब्रिडाइजेशन पूछ रहे हैं, किसी भी मॉलिक्यूल में हाइब्रिडाइजेशन पूछ रहे हैं, they are actually asking the hybridization of the central atom. ठीक है, क्लियर है ये. Let's do some more examples. NH4 plus, NH3, NH2 minus. So NH4 plus, we'll find out steric number of nitrogen. Nitrogen normally has 5 valence electrons. Hydrogen is a monovalent atom, 4 monovalent atoms attached. Charge is +1. So 5 plus 4, 9 minus 1, 8 divided by 2, 4. Steric number 4 hybridization is 3. NH3 का निकालेंगे steric number, 5 valence electrons, 3 monovalent atoms, no charge. 5 plus 3 by 2 is equal to 4. Hybridization is sp3. NH2 minus अगर देखेंगे, number of valence electrons 5, ठीक है, नंबर ऑफ मोनोवैलेंट एटम्स अटैच्ड टू charge is -1, 5 + 2 - -1 is 8, divided by 2 is equal to 4. All these three come to be sp3 hybridized. आ रहा है समझ में? So some miscellaneous examples and hybridization. CO2, CO2 कार्बन डबल बॉन्ड O, कार्बन डबल बॉन्ड O. तो कार्बन का हाइब्रिडाइजेशन निकालेंगे. It has 2 sigma bonds, 0 lone pairs. Steric number 2 hybridization is sp. Let us consider an important molecule called as allele, C3H4. C3H4 has this structure. तो अगर हम हाइब्रिडाइजेशन निकालेंगे तो लेफ्ट वाले कार्बन का स्टेरिक नंबर 3 आएगा, हाइब्रिडाइजेशन sp2 आएगा. बीच वाले कार्बन का स्टेरिक नंबर 2 आएगा, हाइब्रिडाइजेशन sp आएगा. साइड वाले कार्बन का स्टेरिक नंबर 3 आएगा. आ रहा है समझ में? CO2 is sp. Sorry, sp2 नहीं sp. Sorry. CO2 is sp. This way we can find out hybridization. मैंने बॉन्डिंग का कोई असाइनमेंट भेजा है क्या? देखो असाइनमेंट में पेज नंबर 11-12 में सब्जेक्टिव क्वेश्चंस हैं. ठीक है, वो असाइनमेंट के पेज नंबर 11-12 में सब्जेक्टिव क्वेश्चंस है. इसका क्वेश्चन नंबर 1 to 8 करना है. पेज 11-12 सब्जेक्टिव क्वेश्चंस, क्वेश्चन नंबर 1 to 8. डू सॉल्व इट. ठीक है, ये डिस्कस करेंगे. Solving these questions will help you in the learning process. It's important to solve the assignment, solve the booklet. क्योंकि जितना होमवर्क मैं दे रहा हूँ every lecture, do solve it regularly. It will help you in your learning process. ठीक है, so I'm ending the lecture for today. होप सबको क्लियर हो गया. हाइब्रिडाइजेशन निकालना, स्टेरिक नंबर निकालना, हाइब्रिडेशन निकालना. We'll do more examples in the next lecture. ठीक है, बिफोर गोइंग नेक्स्ट टू द वैलेंस शेल इलेक्ट्रॉन पेयर रिपल्शन थ्योरी। ठीक है, चलो, थैंक यू एवरीवन। बुकलेट अभी नहीं करना है।